8.5 is solving log functions. So how do you solve equations with variables in the exponent? That's what the log function's for. When you have a missing variable in the exponent, how can you bring it down so we can solve for that value? I'm going to show you about 10 examples of working through this. And probably the most important thing you need to remember is you're going to change your equation from a log to an exponent or exponent to a log. But that's one of the main rules that if you can remember that, that should be some of your first steps to solving these equations. Okay, so let's remember. Logs go to exponents, exponents go to logs. Okay? That's probably one of the main key skills of being able to do this. Identify what the equation is and what you need to change it to be able to solve that equation. Okay, so solving the logs. We have log base 4, x plus 4 equals 3. X plus 4 is in parentheses, so we really can't do anything with that. We have a log function. Okay? Since everything's away from the log function, logs go to exponents. So this is why we practice that skill. How would you write this as an exponent? 4 to the third power equals x plus 4. The base, exponent, and whatever's here goes to the equal sign all by itself. Now that's something we should be able to solve. We should be able to do 4 to the third power. 4 to the third power is 64 equals x plus 4. Subtract your 4. X equals 60. Okay? So once we switch it around, we should be able just to solve this as the basic equation, do some simplifying, and then get x by itself. Now here we have log base 7 of x minus 10 equals negative 6. The difference between these two problems, that x minus 10 is not in parentheses. So this is not grouped together. You need to get everything away from the log first. So I'm going to add 10 first and get log base 7 of x equals 4. And now, since everything's away from the log, now we can take that log and put it as an exponent. 7 to the 4th equals x. So x is on to be all by itself. The only thing to do now is do 7 to the 4th power. I have that as 2,401 equals x. Right? So here's two examples. We started with logs and we wrote them as exponents. Okay? Logs go to exponents. I'm going to say that a lot this chapter. If you can remember that, you should be on your way to being able to solve these. So here we have 8 to the 2x minus 5 power equals 64. Okay? So here we have our missing value is up in the exponent. It's an exponent equation. So we're going to take this exponent and we're going to write it as a log. Log base 8 of 64 equals 2x minus 5. So here we have a log that we need to be able to evaluate. Like I said before, when we did this in the first couple sections when we introduced the logs, some people have to change a base on their calculator, the function. Some of you don't have to do the change of base with the division. So you're not have to just be able to somehow do log base 8 of 64. Once you plug that in, I'm hoping you guys see that it should simplify to 2 in this case. So we should get 2 equals 2x minus 5. Make sure I write it down correctly. Now it's the basic solve. Add your 5. Divide by 2. 7 over 2 equals x. If you want to write that as 3.5, I'm fine with that. 3x minus 10 plus 2 equals 35. Now for this one, that 2 is not a part of the exponent. So we need to get rid of that 2. Kind of how we had to get rid of the 10, you have to get everything away from the power first. So I'm going to subtract 2 from both sides. 3x minus 10 equals 33. And I'm going to now rewrite this as a log. Since everything's away, we're going to have log base 3 of 33 equals x minus 10. So log base 3 of 33. This again, you have to use the change of base to evaluate it. I have that as 3.5 13.183 equals, and that x minus 10 staying what it is. So we have x minus 10. I'm going to add 10 to both sides. 13.183 equals x. Okay, right, you're allowed to give me decimals. You're not going to get a lot of nice answers here. A lot of times those log functions, that's why we have the change of base, you're not going to be able to get a nice integer answer. Okay, so round to 3 decimal places and we should be good. So these were exponents. We did some logs, we did some exponents. Now, if you get a problem that has logs on both sides of the equal sign, log base 4, log base 4. In this case, since they're the same base, this actually simplifies 4s pretty nicely. Those logs are going to cancel each other out. Log base 4, log base 4. But it's only because the bases are the same. Same bases can cancel each other out. 5x minus 12 equals 2x plus 3. And now it's the basic solving again. Okay, so just take your time. Don't rush through this. I know everyone just wants to, you see this, it's something that you've been doing since probably 6th grade. Take your time and think through the process. Make sure you're showing your work. Subtract your 2x. Add your 12. X equals 5 after you divide by 3. Now here we have 5 to the x minus 2 power, 5 to the 4x minus 9 power. The bases are the same again. If you have the same base, those bases are going to cancel each other out. So we have x minus 2, 4x minus 9. And again, it's a basic equation. Collect the variables. I'm going to subtract x over here. We get negative 3x minus 9. Add my 9. 7 equals 3x. 7 over 3 equals x. Okay. Check my work there real quick. Yeah, it looks good. Okay. So take your time when you're going through this basic solving. So here were 6 examples of just either dealing with the log or the exponent. Okay. On the next video, we'll look at natural log and some problems where you're going to have to do some condensing.